In this video, we're going to take a look at how to use integration to find the length of a curve between two values. There's two types of questions we can get. We get both of these formulas in the booklet. It depends if it's Cartesian or if it's parametric. We're going to start with the Cartesian one. It says find the length of the curve, cosh from 0 to ln2. So the cosh function looks like this. It crosses the axis at 1. And from 0 to ln2, we're just going to work out what this length is here. Okay, so all we've got to do really is look in the formula booklet, set up an integral. Think about what 1 plus dy by dx would look like. Sorry, dy by dx squared would look like. So a nice place to start before we sub into this integral is just obviously differentiate. So cosh differentiates to sine. So 1 plus sine squared. And think about the identity that we could use, which we also get in the formula booklet, cosh squared minus sine squared would be equal to 1. So 1 plus sine squared would be equal to cosh squared, which is quite nice actually, because if you look at what happens now, we could say s would be equal to the integral from 0 to ln2 square root of 1 plus sine squared, which would be the integral of the square root of cosh squared. Which is just the integral of cosh. Do set the integral up, like make sure you write the integral, you put the limits in, because quite often you'll get like an independent mark just for this. So even if you get the answer right, you will need to set your integral up properly, just like in every sort of integration question. Don't skip these steps. Okay. So the integral of cosh should be sine. Limits ln2 and 0. Now obviously we know the identity for sine is e to the theta minus e to the minus theta over 2. So when we sub ln2 into this, it'll tidy up. I also know that sine of 0 is just 0. I mean, you can just, hopefully by now we'll know this, but just think about the graph. Sine of 0 would just be 0, wouldn't it? Okay. So that will give me 2 minus 2 to the minus 1, all divided by 2. So it's 2 minus half, 3 over 2, divided by 2, so 3 over 4. And don't forget, this just represents a length. So if there are units in the question, it would just be those units. It's not an area. Even though we are using integration, we're finding a length here. So whatever that units would be would just be units, if there was a context. Our second example, a little bit more complicated. We've got parametric. Okay, so we've got x equals t minus sine t, y equals 1 minus cos t. And the question's set up in two parts. It's like a show question. So show dx by dt squared plus dy by dt squared looks like this. The reason why they're doing this is like, if you weren't able to do this show part of the question, you could still use that result in the next part of the question when you come to integrate. But let's start with part A. So we've got dx by dt. It'd be 1 minus sine becomes minus cos. Dy by dt, so minus cos goes to sine. So we got dx by dt squared, which would be 1 minus cos t squared. Dy by dt squared, which would be sine squared. If we expand this out, that would give us 1 minus 2 cos t plus cos squared plus sine squared. Looking at what we're aiming to get to, it's a bit of an unusual thing, like sine squared t over 2. And there's not like, if you look at this, all these are t's. I'm thinking, well, where's this t over 2 even going to come from? I mean, maybe pause the video just for a second and think about how you can get from this to this. Okay, so the key to doing this is to notice that when the angle changes, in this case the angle's being halved, right? So this angle is half of this angle. In other words, this angle is double of this angle. There's an identity that we can write from double angle identities in terms of cos 2 theta, which has a sine squared in. We should know that cos 2 theta is equal to 1 minus 2 sine squared theta. Let's try and compare this with like a form that we've got here. So we could say that 2 sine squared theta would equal 1 minus cos 2 theta. Look at what we've got then. So if we multiply everything by 2, 4 sine squared theta would equal 2 minus 2 cos 2 theta. 4 sine squared. If theta is t over 2, that would be 2 minus 2 cos. Double this angle would be t. If you guys can't see that. So this expression here, we can write in this form. With it being a show question, like it depends, if you want to do this workout on the side, that's fine. Like I would always start with the identity and rearrange it. Or if you want to work backwards and sub in, that's also fine. But I think that this would clearly show where this answer comes from, wouldn't it? So as long as you did this working out, you could say that this was equivalent to 4 sine squared t over 2. Now that we've done that, we can actually use this result because we have to find the length. I'm not going to draw this one. You can actually draw this parametrically if you go onto your graphical calculator. If you just change the type to parametric, you could enter these two functions to see what the curve looks like. But we're just trying to find the curve between, from t equals 0 to t equals 2 pi, if you think about it, like t equals 0 would be there, all the way around to t equals 2 pi. So we're just finding like the full arc length of this, like one rotation of this curve, okay? So set up your integral. We're going from the limits have to be t values because it's a parametric integral, so from t equals 0 to t equals 2 pi. If they ever gave you the limits as x values or y values, you would have to write these limits for t, okay? dx by the t squared plus dy by the t squared. Again, this is just in the formula booklet. So if we square root this, we get 2 sine t over 2 dt. And then we just have to be careful as we integrate. Anti-clockwise. Take the 2 outside, if you would prefer. Sine goes to minus cos. A half of t, so remember when we integrate we divide. Dividing by the half means you're multiplying by another 2. The limit's 2 pi and 0. So we get minus 4 cos of pi minus 4 cos of 0. So that becomes minus 4. Cos of pi is minus 1. Minus 4. Cos of 0 is 1. So we get 4 plus 4, which is 8. And again, don't forget this just represents a length. So if there was units, it would just be those units, not squared. Alright, thanks guys.